Hi, and welcome to this demonstration of using RTOS with printf. We're going to see what the problem is in this video. We know in the previous video we hit a hard fault, but I want to show why we hit a hard fault. Just to show you it happens on any project, I've created another one here where I'm using timers. The previous demonstration I was using 2 tasks. Here I've got 2 timers. Okay, so I've got one timer is a periodic timer, and the other one is a one-time timer, and then I've also got a task running as well. So we're going to start this running here in just a moment, and I want you to notice in my callback functions that get called when the timer fires, notice I do have a printf, and notice I also have a breakpoint on each one of those. So let's get our code running. I've got my IoT discovery board connected up. Click on the debugger, and we'll say switch. Now remember, in the previous video we hit printf, and we ended up at a hard fault. So this one I'm going to show you how we get there. So let me do a step at a time. So normal initialization, this has nothing to do with RTOS at this point. All right, that's just the board. Now we're getting into RTOS specific. So here we're going to create a timer, and I'm going to set that timer to start in 2 seconds. That is 2000 milliseconds. Start that timer up. Now remember, at this point the timer is not running. It's not started up because we haven't started up RTOS. Right? This just is initializing everything for us. Also, let me make a point. We are using the CMSIS functions here, so OS timer def and OS timer create, but we know that those go down into FreeRTOS specific functions as well. So let me continue to step over. Here's my second timer. Notice this one is a one-time timer, so it'll fire one time, and I've got it firing 5 seconds after. So now let's set up our task. So we create a task, and at this point we're ready. Oops, I didn't mean to go into that. Let me step up. At this point we're ready to start RTOS. When we come here, let me step one more time. When we come here, when I do this, when we start everything up, I'm going to say resume at this point, because I've got breakpoints where I want them, so I'm going to go ahead and do resume. And boom, we've hit our first callback. Now I want you to notice here in the stack trace, we initialized our stack, we had a timer task, we processed the timer, processed the expired timer, and we are now in our callback. Now what I'm going to do is step down into this printf. Boom. This is why we are crashing. This is why we are crashing. And to be very clear on this, notice suddenly we're into this sbrk, which deals with malloc. The printf function is actually calling malloc. And a very important point about FreeRTOS, or really any RTOS, it uses a totally separate memory management allocation. It does not use the C runtime allocation here. To stress that, remember back in the lesson where we covered memory management, we talked about FreeRTOS kernel objects, things like tasks, queues, semaphores, and they can be either dynamically allocated or statically allocated. But this bullet here, FreeRTOS does not use the C language malloc and free, but rather FreeRTOS specific calls. And actually we talked about why it doesn't use it. But the key thing here is it's being used. And who is using it? It's printf. Now to show how this causes problems, when you call sbrk and you pass in a value of 0, which notice increment is a value of 0, you're actually wanting to find out where the memory breaks at. This is basically to find out where your heap is at. And notice they have something when you come into this, they have something called end and heap end, and they're saying if heap end equals 0, and notice right now when I put my cursor over heap end, it does indeed equal 0. So if I step over that, we're going to set it to end, to this value of end. And I come in here, and notice I'm going to take my heap end, and then I'm going to add it to whatever increment comes in. Well, remember the increment is 0, and we're going to check to see if it's larger than the stack pointer. If it's larger than the stack pointer. So the way the heap works, the heap is below. When you're looking at memory, the heap is in the lower part of memory and the stack is in the upper part of memory. The stack grows down, the heap grows up. So you want to make sure they're not hitting each other. So when I step into this, boom, we're getting an error. Whoa, we're getting an error, because what the heap is saying and what the stack pointer is basically saying, your heap is bigger than where the stack is at. This is why we crash. In fact, you see we're getting error no mem. We know we have plenty of memory in the system, but where the pointers are at are all messed up because the runtime, the way the runtime's managing memory and the way FreeRTOS is managing memory is totally separate. So let me continue to step. Let's see, I think what I'll do is, let's see if we say resume. And we come into this again. In fact, we'll see we'll hit this multiple times, but each time, notice we're getting no memory. So every time you get to this, this is telling you that somewhere in the environment, in fact, now we see here this callback 1 was doing a printf. Printf is eventually doing a malloc. And this is perhaps the core piece of information to understand, is anytime you're calling these C functions, they may very well do a malloc. And if they do a malloc when you're using FreeRTOS, you're in trouble. So let's run again. Here we are again. I want to show every time they come in, they're getting the same, hey, no memory. So let's run again. Keep running here. Ooh, there we are. Hard fault. Hard fault. And so the core issue I want to stress here, and you saw it very good in this demonstration, is that mixing the C library with FreeRTOS without making any changes ends in this hard fault. Now in another video, I'll show some ways around this. But what a lot of RTOS projects do to get around this is they do not use this C library at all. But in another video, I'll show you an alternative, how you can make some changes to it and use it if needed. Okay, so I recommend you go through this same demonstration. Again, it's a key message to know. I'll end back on this. FreeRTOS does not use the C language malloc and free. And if you ever find yourself using some library code in FreeRTOS and suddenly you see it call it malloc or free, then you know you're in trouble. In fact, you'll know it because you'll get the hard fault. All right, I'm Norman McIntyre. Thanks as always for watching.